Man's imagination knows no limit. Neither, it seems, does his creative power. This super express train speeds its passengers to their destination at up to 250 kilometers per hour. The know-how that made the super express possible led to the development of the magnetically levitated train. It can reach a world record speed of 500 kilometers per hour, riding on a cushion of air and driven by a superconductive magnet. Using fiber optics, it's possible for a thread of glass fiber thinner than a strand of human hair to carry 1,500 communication circuits. New developments are taking place in forced agriculture too. In the laboratory, data obtained through light synthesis is analyzed and used to establish the ideal conditions for plant growth. These vegetables reached maturity in only 1/3 of their natural growing time. Also under study now is a new generation of industrial robots. This robot can assemble a vacuum cleaner, a process requiring high precision and a complicated program. Such technological creativity has depended and will continue to depend on the power of electronics to process and convey information. The Marunouchi district of Tokyo. This is Japan's Wall Street, the focus of international finance and trade. Excuse me, do you mind if I ask you something? Do you have any electronic products with you? Your watch, for example. A watch used to consist of up to 140 component parts. Electronic science has condensed this complex mechanical system to a simple module. Anything else? A calculator, providing instant answers to complicated mathematical problems backed up by an excellent memory. Compact electronics replace bulky mechanical devices and provide irreplaceable support both in business and the home. Progress in electronics has gone hand in hand with remarkable progress in materials, devices, and production technology, so that whole sectors of industry now depend on advanced electronic systems. Nothing in the wide span of human history has progressed so far, so quickly. First came the vacuum tube. (1946) saw the birth of the world's first computer, using as many as 18,000 vacuum tubes and generating exceedingly high temperatures. Two years later came the transistor, which immediately outdated the vacuum tube. Compact, with low electricity consumption, the transistor generates almost no heat at all. The transistor was miniaturized still further in 1960. with the development of the integrated circuit. One IC, only a few millimeters square, contains hundreds of transistors. Today's large-scale ICs contain tens of thousands of transistors. The computer, and sometimes only the computer, can solve complex organizational problems. Advanced train reservations, for example, covering a busy network. Computer hardware combines with sophisticated software in a nationwide reservation system. Through computer control, the chance of human error is reduced to a minimum, so that 300 Super Express trains a day can operate according to a precise schedule and in complete safety. The end of a day's work for some is just the beginning for others. The morning paper goes to press long after most people have gone to bed. Articles are edited automatically and transferred onto perforated tape. The tape is fed into a computer and typesetting is performed quickly, efficiently, and accurately. The news is in print within hours. Computers also make a contribution to safety in the skies. In any one day, they are used in the traffic control of some 1,300 planes landing or taking off at Japan's numerous airports. Air traffic control once depended on radio contact with the pilot. Now it's fully automatic. Altitude, weather conditions, and so on are processed by computer, and the data is used to guide the plane down the runway. Electronics are also making our cities safer places to live in, providing vital support for the police. In Japan, the conviction rate for all crimes is 81%, a rate that can only be maintained through the computer processing of huge volumes of information. The start of another working day. The rush hour reaches its peak, and time is saved by the use of automatic ticket barriers. The pace of modern life creates a huge demand for energy, including electrical energy. Energy consumption at steelworks has been dramatically reduced by the introduction of electronic technology. Power is now recycled utilizing blast furnace gas pressure to generate electricity. This economy represents 13% of total energy consumption, enough to supply 2 million households. Japan's steelworks lead the world in productivity and have an equally impressive record in energy conservation. Computers minimize waste by guaranteeing production exactly according to specification. Today, in the automotive industry, car design and its relation to function are analyzed automatically. Robot welding economizes on working hours and improves production efficiency. Electronics also contribute to quality control. The number of components can be substantially reduced, simplifying assembly. In this factory, computers are manufacturing computers. In Japan, computer production is expanding by 19% annually. At the moment, only the United States and Japan have the capacity to export large-scale computer systems. A computer-controlled production machine. "55% of the world's numerically controlled machine tools are manufactured in Japan." One of Tokyo's new shopping and business complexes, housed in the Orient's tallest building, has the world's fastest elevator. The rate of acceleration is precisely controlled so as to maximize passenger comfort. Operating speed is 600 meters per minute. Electronically controlled smoke and heat sensors give early fire warnings in high-rise buildings. The sensors are directly connected to the building security center. Instant reaction to the symptoms of fire can limit the spread of fire and smoke, saving lives and reducing damage. Data processing and communication systems have come to play an important part in everyone's daily life, at home and in the office. A fully automated copying machine. A facsimile, using telephone lines for instant transmission of both photographs and manuscripts. In this traffic system, the sequence and timing of signals can be adjusted to suit traffic flow. Sensors and cameras at strategic points feed data back to a control center. And an even more advanced traffic system is under development. The driver supplies the code for his destination to a terminal in the car. A computer then automatically indicates the least congested route. Another control technique is being used in the development of an unmanned transportation system in the city of Kobe. And even medicine is benefiting from the power of electronics. The body is being probed and examined with an accuracy never realized before. The vital component of all electronic equipment is the integrated circuit. The production of ICs makes use of photographic techniques. The circuit design is drawn automatically by computer, cut out, and photographed. The process is repeated and then printed in actual size to form the photo mask. The mask is placed over a wafer of silicon and exposed. The photomask corresponds to a photographic negative, and the silicon wafer to the printing paper. Once developed, the silicon bears the imprint of the circuit pattern. The sensitized area is then etched, leaving the circuit pattern engraved in the silicon. Etching is followed by the diffusion process. Gas osmosis on the exposed silicon creates the transistor. The sequence is repeated again and again to produce a fully printed IC. The final processes are bonding and packaging. The strictest environmental control is essential throughout every stage of the exposure process. Every particle of dust larger than half a micron must be eliminated from the atmosphere. Sensitizer is applied to the silicon wafer. During the exposure process, the wafer is transported on a cushion of air to minimize contamination. The process of diffusion is an extremely complex one, and its techniques are very sophisticated. Finally, the circuit pattern is finished. The printed wafer is cut into chips. Then each chip is bonded to its lead wires. The incredibly fine process of bonding used to be done manually. Now it's done at 6 times manual speed using full automation, raising quantity as well as quality. Altogether, ICs and LSIs go through 200 production processes. Among the latest electronic developments is the microcomputer. This was developed through the technology of the LSI. Now, too, there is the Super LSI, a chip containing hundreds of thousands of transistors, an important new technology. Electron beam lithography, which made the Super LSI possible, was developed in Japan. In 1974, according to the Nomura Research Institute, world production of ICs was valued at $2.49 billion US. By 1979, this figure had soared to $6.95 billion, with Japanese production having quadrupled over the same period. Japan now ranks second in world IC production. In 1979, exports exceeded imports for the first time. The two most outstanding advantages the IC holds over mechanical devices are compactness and reliability. Nowhere is this seen better than in space technology. Japan has now joined the United States and Soviet Union in successfully launching its own fixed satellite. Fully automated production is another area in which electronics has played a major role, raising economy, efficiency, and product quality. Japan produces 90% of the world's videotape recorders, which demand ultra-sophisticated precision technology. And now, there's the new video disc system. Nara, one of the ancient capitals of Japan. Here, an experiment is underway in two-way TV communication. Viewers can actually participate in TV programs through a camera and microphone terminal installed on the receiver. Japanese trading companies, on the other hand, are concerned with massive quantities of information which they process around the clock from their branches all over the world. The official working day ends. But the electronic hardware and software never ceases to receive, analyze, process, and instruct, keeping the wheels of society and business turning. One of the latest ideas is that these computers can be instructed by the human voice. One voice-controlled system is already being used in the handling and sorting of merchandise. Communications in the Japanese language involving 7,000 different characters have already been greatly simplified by the character terminal display and computerized Japanese language typewriter. Electronics are playing an important role in the most urgent matters of medical science. Here, surgeons are examining the efficiency of an artificial kidney implant. One day, this technique may save the lives of countless human patients. A revolution in marine transport is on the horizon. This model is propelled by a semi-permanent magnet using a superconductor with an electrode plate attached to the hull. When the electrode plate is electrified, the reciprocal action of the magnetic fields pushes the water back and propels the ship forward. The ship can be ordered into reverse motion at the flick of a switch. The superconductive magnet has major energy-saving potential. Speeds of up to 100 knots or 185 kilometers per hour are possible. Electronics are being used in the development of new materials. This new carbon fiber and resin compound has a tensile strength 6 times that of iron. First, acrylic fiber is burnt to make it fireproof. Then the fiber is carbonized by exposure to temperatures of over 1,000 degrees centigrade. The carbon fiber is then impregnated with resin, producing the finished compound, seen here under an electron microscope. Lighter than aluminum, yet stronger than iron, this compound is replacing many standard materials in a wide variety of industrial applications. The linear motor trade, cars, aircraft, aerospace technology, for example. Electronics are shaping our world. And in the future, their role will become even more important and their technology even more refined.